Welcome back. Log properties, and basically this is just a practice. Now you should understand the log properties, and of course if you like, you can watch the video on those log properties. I did make them. I'll put up a link up above there for you. You will be utilizing them. Now in grade 11, it will depend really on the teachers you have and how far they're going to push you on understanding logarithms. But if you continue into grade 12, or if you do kind of things like advanced functions or calculus, and then you carry on into further mathematics or sciences, engineering, it's certainly worth your time to understand logs because they will creep up on you quite a bit. So I have 10 questions here for you. I will put up a link so you can download this practice for yourself. I'll put it down below in the show notes. And then once you go through it, you can come back and then see I will solve every single question. For some questions, I will not use a calculator at all because I will want you to think of the log properties. And then for other questions, we'll use the actual calculator to also help us a little bit and understand some concepts. Now, I will try to also highlight the properties themselves that you actually have and that you're actually using in order to be able to solve these. So let's get started. So question 1 is a simple question in the sense that it just asks you to evaluate this log of base 5, and that is of 625. Now it says do not use a calculator. And this will depend, of course, on how good you are with your powers and exponents and so on. Now 625, I actually do know so I can rewrite this. It's going to be log base 5, and this is going to be 5 to the 4. Because as you can see, so 5 squared is 25. 5 cubed is basically 5 times 25, which is 125. And then multiply that by 5, which is going to be 5 to the 4. It's going to be 625. Now, the property that we're going to use is we know that we can bring the exponents, okay, so within here, okay, right to the front. So this is going to be log of 5 of 5, so 4 multiplied by that. But this right here, log of a base of the base is just simply equal to 1. So 4 times 1 is just 4. And right away, you could have been able to say that right here as well. So the answer to question 1 is 4 without using any kind of calculator. Now let's take a look at number 2, which says evaluate. So again, there is a log. We are not using a calculator. Now for this one, maybe I'll copy it down for myself, and I'm going to bring it in here and then solve it. So the property that I will use is when you have multiplication within here, you can actually write this out. So this is going to be log of 3 of 81 plus log of 3 of 243. So you can do that instead of multiplying the 81 times 243 and then trying to figure this out, especially when they say, do not use a calculator. So this right here, okay, so, 81 itself, it doesn't mean that it's easy, but this, you will find that this is going to be log of 3, and now 81. Okay, so I kind of know that 3 cubed is 27, and then 27 times 3 is going to be actually 81. All right, so this is going to be 4. Plus, this is now log of 3, and this is 243, which is going to be just 3 to the 5. Because 81 is 3 to the 4, and therefore, so 81 times 3 is going to be 243. And now, from here, you can use again. Now, you don't always have to drop this in front like this, right? At some point, you probably will see that that is the property that you're using. So this really is just 5, and then the log of 3 of 3. And this right here, okay, is equal to 1, and this is equal to 1, again, by the properties. And so therefore, this just simply means this is going to be 4 plus 5, which is 9. And that's the answer to question number 2. And I use those properties to evaluate it. Now let's take a look at number 3. So again, I'm going to take this and bring it down. So copy. Let's put it right here. We have, all right, so I have log, well, right away actually this one. So log of any base, and if it's of 1, this comes out again through the property. This is going to be equal to 0. Okay, so that's the one of the properties that we use. So log of any base, okay, of the number 1 is 0, because that's the exponent that you would need to make something equal to 1, which really means this is just log of base 4.4 plus log of 128, and base 4, well, again, so I'm going to use the property here, so kind of go backwards. This is going to be log of 4, 0.5 times 128. So I'm using that property. And now 0.5 times 128. So this right here is going to be 64, right? Because 0.5 is 1 over 2. So 128 divided by 2 is 64. And now log base 4, 64. So that is going to be, I guess, well, 4 squared is 16, and 16 times 4 is 64. So that's going to be log base 4, 3. So I'm not going to keep dropping it in front. Okay, so now you can see that this is just going to be equal to 3. That's what you have for this example. Let's continue and try to see. Okay, so question number 4. And so that's this one right here. So copy. So far we've been using the kind of multiplication properties that we have. Here's a subtraction, and right away, so within subtractions, now if you can tell, so log of base 2, now 48, 32, so no, so that doesn't go in, so it doesn't have an even exponent on it. Log of base 2 of 3. Okay, so what I'm going to do here is I'm going to use the property because of the subtraction, which means basically division. I can bring that in, and that's going to be log of base 2. Now 48 divided by 3, and that's going to be what, 1, that's 16. And now, well, so this, so log 2, this is 2 to the 4, which equals to 4. Okay, so that's this example. There you have it. So without a calculator and just using the property itself. Okay, so that's that question. So that was question 4. Question 5. Let's see what this one has to offer. So question 5 right here. Log of base 5, so 25 over 625. So it's division. So I guess I can use a subtraction. Now, actually, 25, 625, I'm going to reduce that. 25 goes into 625. So if it goes in, so what is that going to give us? Okay, so, well, 25 goes into 625, actually. How many times does it go in? So don't use a calculator. I'm just thinking. So 10, about that's 25 times. So this is going to be log base 5 of 1 over 25. That's that. So that's equal to, and notice, well, I guess log 5, 1 minus log of 25. Okay, so 5. Okay, so that's not bad. So this one is 0, right? It's going to be equal to 0 minus, and this is 2. So this is just negative 2. Actually, which makes sense, right? Because, notice, so 5 to the negative 2 is indeed 1 over 25. Okay, so there you have it. That's question 5 for us. Let's see what else they have. Question 6, change the base. Okay, so we're going to be using the base. Now they're asking E, which is Euler's constant, or Euler's number. So we're going to see what that gives us. All right. Log, this is 7 of 18. So if we're going to change the base to E, so this is going to be log of E, okay, 18 divided by log of E of 7, which really means, so let's not forget, this is ln of 18 divided by ln of 7, right? Because that's exactly what log of E means. So that's just ln. And now use calculator, round to the 100th. All right, so let's see it. Here's ln of 18 divided by ln of 7 equals, let's see what that gives us. Oops. That's going to give us to the 100th. So 1.48535. So it's that if we round it off. Okay, so that's just a change of base property right there. Let's continue. So for question 7, okay, now this is the same thing. They're saying change the base to 10, okay? So, and those are the two. So ln and log on your calculators are the ones that we typically use. Now they're using the same thing. So log of 7, 18 equals, so this is going to be log, right, base 10 of 18 divided by log of base 10 of 7. But of course, we don't have to write, this is just that, because we know that log is of base 10. And now what this gives us, and this should not surprise you, so log 18 divided by log 7, which is exactly the same thing. And it says, you know, what do you notice about questions 2 and 3? I guess not 2 and 3. This is questions, I guess, this is 6 and 7. 6 and 7, okay? And what we notice is that they're identical. Okay, so these two. And that's exactly true, right? They are identical because when you change your base, it doesn't matter what you change your base to, it's always going to be equal to this. So you could have said you can change the base to 2, to 3, to 10, to Euler's constant, to anything. Now, of course, it has to be positive. And that's what you will get. Okay, so as long as you change it to a positive base, okay, not equal to 1, this is what we're going to obtain. All right, and that's going to be always the case. And that's the beauty with the changing of the base, that we can do that. So let's continue. Now, question 8. So here, copy. Let's paste it. So solve for x, all right, so we have 4x equals to 42, round to 3 significant figures. If you've forgotten about significant figures, or if you have actually never learned it, because not everybody always learns it, I'll put up a link up above there, something typically that should be covered at elementary school, maybe in grade 9, one of maybe your science courses. So I'll put up a link there. You can link and go back if you wanted to. All right, so 4 to the x is equal to 42. Now, what we're going to use, okay, is we're going to try to solve. Now, of course, you may remember, all right, so sometimes when it's already in this form, because this is an exponent form, we know that this really means, okay, that x is equal to log of base 4 of 42, right? These are equivalent. And so from here, you can just find out exactly what log of base 4 42 is. You can change the base to either Euler's number, so you can use ln, or you can use log. Okay, you can change it to base 10 and then find the answer. Now, very often what you will find is that math and science teachers or instructors, or even you yourself, at some point what you're going to have is you're going to use the property of the same base, where you're going to take the log of both sides. So, you know, instead of going directly to this, sometimes you might see it like this. People might write, okay, let's take the log of base 4, okay, of this, and this is what they're going to do. And they're going to do that to both sides. Now, it's an additional step, but sometimes it's a useful step to remind us. And the reason why they do this is because, again, this x will drop down to the front, right? Because that's of the property. And then this right here is just equal to 1. And it's, since this is equal to 1, really what you get x times 1, which is x equals 2 log of 4 of 42. Which is what we had here, if you remember. I mean, if you remember that these two are equivalent, then you don't have to do this extra step. But very often you will see that extra step as a reminder. I know that I sometimes use it as well, but not always. So in any case, so if I want to be able to solve this, I'm going to, well, just for the heck of it, I'm going to change the base to e. So I'm going to use ln. You can use log, and you're going to get the same answer. So let's see it. So ln of 42 divided by ln of 4 equals, so this is 2.69615, so on. Now they said 3 significant figures. Well, so these are 3, so I'm going to round it to 3 significant figures. 2 point, and this is going to be 70. So I'm going to keep that 0 here because that's the 3rd significant digit. That would have been my answer. Let's see what else they ask us. So that was question 8. Question 9. Let's copy. So I guess another solving. So these ones are kind of neat. I like doing these solutions here. So let's solve this one. Okay, so this one looks a little bit more challenging. So 2 plus x equals 2, 1.5. Okay. All right, so this one is pretty neat. So in order to solve this, now notice I have a log, and I'm going to have to use the property where I'm going to take, okay, so this right here, that's my base. So I'm going to raise everything to my base, and this is the property you may remember or you may not remember. Okay, so the property I'm going to use, I'm going to write it here at the bottom just as a refresher. When you have a base and you're to the exponent of log of the same base, okay, of, let's say, k, this just equals to k right here. Okay, so that's from that property. If you don't remember those initial properties, maybe I'll put up a link to that as well for you, okay, right there. So I'm going to be using this because what I'm going to say is I'm going to do both sides. I'm going to raise it. Okay, so I'm going to do this. Okay, and what I'm doing it is I'm taking the left-hand side and the right-hand side, and I'm taking the base of 5 and I'm putting it, okay, as my base to both, which means, okay, so now right here, this right here is going to be just equal to 2 plus x, which is exactly coming from here. So notice that's from that property. That's coming from right here because my base is 5 and then my exponent is log to the 5, okay, of that base. And then here, so equals 2, this is 5 to the 1.5. Now, okay, my x equals, so it's going to be 5 to the 1.5. I'm going to bring that 2 to the other side, and I've just solved for x. So what does that x equal? So x equals 5 to the exponent of 1.5 minus 2. equals. Now that's my answer. They say round to 3 significant figures. Okay. So it's going to be 9.18. That's 3 significant figures. So there you have it. So that's that. All right. Let's see. What else do they ask us? Solve for n. All right, so another solution. So here, copy. Let's paste. Round to 1 decimal place. All right. So let's try it. So we have 100. This is 1. Well, that's addition in the brackets. So that's going to be just that. To the n equals to 300. All right, so that's there. So now we're going to have to solve for n. Well, okay, so my n is in the exponent. Okay, so first thing that I'll actually do is I'm going to divide both sides by 100 to get rid of this right here. So I'm going to get just 1.015 to the n equals 2, 3. So that's what I have there. Now, all right, so again, notice it's basically in my exponent format. And so what I'm going to do is I can just transform it because I'm solving for the exponent. Okay, so in this case, I can say n is equal to, and then I can pick my base, whatever base that I want. Okay, so I can do it directly that way. Okay, so I'm just going to show you here. So both sides, okay, so what I will do is I'm going to take the log of both sides with the same base. All right, so I'm going to do this. So log of 1.015. Okay, so I'm just kind of going and showing an extra step. So this will drop down to the front. So it's going to be n, and all of this, so this is equal to 1 by our properties. So that equals just n equals to log of 1.015 to 3. Again, that shouldn't surprise you in any way because that's exactly what it would equal, right? That's just the equivalent between a log and then the expression as an exponent. And now you can use whatever you like. So in this case, okay, let's use base 10, so log of 3 divided by log of 1.015, and we'll get our n. Okay, so in this case, log of 3 divided by log of 1.015. That's going to be 73.8. They said to 1 decimal place. Yep. Okay, so there we have it. So that would have been my answer. And that would complete, this kind of practice handout on all of these. And, so those properties are super useful to be able to solve for an unknown or be able to just to solve for some logs or sometimes even exponents. Okay, so thanks for watching. We'll see you in a future video. Bye, everybody.